Dear students, I am Nilanjana Sanyal, an online math tutor from India. I tutor students of the IB and the IGCSE boards from grades 9 to 12. This is my website www.nsonlinemathtutoring.com. You may visit my website to know about my tutoring services in more detail. Okay. Now we have learnt about the finite geometric series. This time we will be learning about the infinite geometric series. What is the meaning of this term geometric infinite series? Suppose we are having an infinite geometric sequence, that is 2, 4, 8, 16, 32, dot. This is an infinite geometric sequence. If I want to get the summation of this infinite geometric sequence, that is, I'll be converting it to an infinite geometric series, that is 2 plus 4 plus 8 plus 16 plus 32 plus dot. Okay. Now the first thing that comes to our mind is whether it is at all possible to get the sum total of an infinite geometric series. The answer is both yes and no. Let us see why I am saying this both yes and no. Let us first try to find the sum total of this particular infinite geometric series. I start with getting the sum total of the first three terms. It is 2 plus 6, 2 plus 4 is 6, 6 plus 8 is 14. Now I'll be just going on adding the terms. I have started with 3 terms. Now I add this one, 16. 14 plus 16 is 30. I add the fifth one, 30 plus 32 is 62. So I'm seeing as I am including more and more number of terms, the sum total is increasing. Okay. And we know the formula for getting the sum total of the first n terms of a finite geometric series. So I will be applying this. Of course, this is not a finite geometric series, but I will be seeing, I'll be taking, say, the first 100 terms or first 1000 terms, and I'll be seeing how is the sum total varying. What is the change, or is there at all any change in the sum total? Okay. So let us start. The first term U1 is for this series is 2. R is the common ratio for this series. It is also equal to plus 2 because 4 over 2 is 2. And n is equal to, we are trying to find the sum total of the first 100 terms. So n will be equal to 100. Okay. So I use a calculator. 2 times 1 minus, and I have used this form to U1 times 1 minus R to the power of n divided by 1 minus R. You have the other form as well where it is Sn equal to U1 times R to the power of n minus 1 divided by R minus 1. You may take that one as well. Doesn't matter whichever form you may take, you will be getting the same answer. Okay. So 1 minus 2 to the power of 100, and then it is divided by 1 minus 2. So what is the value of this? 2.5353 times 10 to the power of 30. It's quite a large number. Obviously it has to be large because it is increasing. We have come up to 62. Okay, and this is the sum total of only the first 5 terms, and now we have taken the first 100 terms. So now next, let us take first 1000 terms and let us see how is the sum total changing. So 2 times 1 minus 2 to the power of 1000 this time. Okay, and divided by 1 minus 2. You see, it was previously 10 to the power of 30. It has got increased to 10 to the power of 301. 2.14302 times 10 to the power of 301. Can you see the change? How much did it get increased, this sum total? When I have taken 100 terms, it was 10 to the power of 30. And when I am taking 10,000 terms, it has moved up to 10 to the power of 301. Okay. So let us try taking the first 10,000 terms. 2 times 1 minus 2 to the power of 10,000. Yes. Divided by 1 minus 2. What is the value? Oh, it has given C infinity, means it is an enormously large number, large positive number. So they have just represented that number as infinity because it is beyond the scope of this calculator. Okay. So you see, I have included only the first 10,000 terms. The infinite series does not only include the first 10,000 terms, it just continues and it has infinite number of terms. And when we have included just the first 10,000 terms, it is an enormously large positive number. That's why the calculator is giving the answer as positive infinity. Okay. So, we definitely cannot give the sum total of this infinite geometric series. It is not possible. We have seen the calculator is giving us an answer of positive infinity. And this is the case when r is greater than 1. In this case, r was equal to 2. What happens when r is less than negative 1? I'm just changing that sequence a little. I start with the first term as 2. The second term is negative 4. The third term is positive 8. Fourth term is negative 16 and so on. This is also another infinite geometric sequence with the first term as 2 and the common ratio as negative 2. Negative 2 is less than negative 1. Okay. Let's see what we get as the sum total of the first 100 terms for this particular infinite geometric sequence. Okay. So we start with the first term is the same. So we start with 2 times 1 minus, this time the common ratio is negative 2. So it is negative 2 to the power of 100. Okay. Divided by 1 minus negative 2. Okay. What is the answer? It is negative 8.451 times 10 to the power of 29. So it is fairly a large negative number. Next we try to get the value of the first sum total of the first 1000 terms. Okay. So 2 times 1 minus negative 2 to the power of 1000. Okay. So this divided by 1 minus negative 2. So it is, what is the value? It is negative 7.14339 times 10 to the power of 300. From 10 to the power of 29, it has moved up to 10 to the power of 300. Such a large negative number. And what happens when we try to take the first 10,000 terms? It is 2 times 1 minus negative 2 to the power of 10,000. Okay, so I come over here, divided by 1 minus and try to get the answer. It is negative infinity. That means it is an enormously large negative number this time. When r is less than negative 1, negative 2 is less than negative 1, we are having, as we are trying to include more and more number of terms, the sum total is becoming more and more negative, and now when we have tried to include the first 10,000 terms, 10,000 terms is not infinity. Okay, an infinite geometric sequence will not be containing only 10,000 terms. It will be just going on continuing up to the infinite term, and infinity is not a number, it will just be going on continuing. Okay, and from that I have just taken 10,000 terms and I am getting the sum total as negative infinity when r is equal to negative 2, and when r is equal to positive 2 I am getting the sum total as positive infinity. Okay, so when r is greater than 1 or when r is less than 1, that means when the absolute value of r is greater than 1. Negative 2, what is the absolute value of negative 2? It is positive 2. Positive 2 is of course greater than 1. Then as the value of n increases, the value of Sn also increases. We have seen that. The value may be positive and negative or negative. That is also shown. I have shown you that we are getting both positive infinity or negative infinity, and before that the positive summations that we have had, they were also increasing, positive or negative summations. Okay, and r cannot be equal to 1 or negative 1, because actually in this formula, if r is equal to 1, then 1 minus r will 1 will be equal to 0, and you cannot have a 0 in the denominator. So you cannot have 1 as the common ratio. What is the geometric sequence with a common ratio as 1? It will be all the identical terms, 2, 2, 2, 2. The common ratio is 1. So how do you find the sum total of this particular infinite geometric sequence? There are infinite number of 2's. It is infinity times 2. Again, you don't get any sum total. And what happens if the common ratio is negative 1? You will be just having 2 and minus 2 alternating. So if you take the sum total of the first 2 terms, you get a 0. If you take the first 3 terms sum total, you get the first term. So either you will be getting a sum total of 0 or you will be getting a sum total of the first term, depending on whether the number of terms you are taking is even or odd. But infinity is neither even nor odd. So how can you say what is the sum total? So definitely r is not equal to 1 or negative 1. And when r is greater than 1, we have seen the series, just the summation just goes on increasing towards the positive side, and when r is less than negative 1, the summation goes on increasing towards the negative side. Okay, and we say the series is divergent. It is not giving us a constant value, as n is tending towards infinity, as n is becoming larger and larger, as I am just including more and more number of terms of that from that infinite geometric sequence or series. As we are including more and more number of terms, the sum total is also increasing towards positive infinity or negative infinity. Okay, we do not get a definite value. It continues to increase in magnitude. Magnitude is not taking the sign into account. It is only the number. It is increasing. Okay. So this is the case when the absolute value of R is greater than 1. That means, what did I say before? When we had started our session, that the answer is both yes and no. Therefore, we cannot get the sum total of an infinite geometric series where the absolute value of the common ratio is greater than 1. So, it is a plain no. We cannot get the sum total. But when is it yes? Let us come to that part. Okay. But when the common ratio lies between -1 and +1, then the expression r to the power of n becomes increasingly smaller as n becomes larger and larger. Okay, let us see. R is lying between -1 to +1. Of course, R is not equal to 0. That is another case. If R is equal to 0, common ratio is equal to 0. So how can you have the next term divided by the previous term? How can you have the common ratio as 0? So R is not equal to 0 either, because from within this range, there is a value of 0 which R cannot take. Okay. But let us take the R value as half. Okay. So if R is equal to half, how does the R to the power of n change? Let us see that. Okay. Half is 0.5. I can write half. Okay, let me write half and show you for once. Writing half is a bit difficult. That's why. Not difficult, but it will be taking some more time. So this is actually, before taking this, let me include this. Yeah. So it is half to the power of, say, I take 10 or say 4. I start with 4. Half to the power of 4. And it is 0.0625. Okay. Now I take half to the power of 10. Again, I'm every time forgetting this. Yeah. So this one is half, and we come to this part. It is to the power of, to the power of 10. It is 0.000977. Can you see? As I am increasing the power, the value is decreasing. Let's take r to the power of 100. What happens? It's this type. I have done it. Yeah. So it is 100. It is 7.88861 times 10 to the power of -31. See, can you imagine how small this number is? Okay, so as you are moving, let me take 1000 and show you. Okay. To the power of 1000. It is 10 to the power of -302. So you can imagine how small this number is. So as we are increasing the value of n, the number is becoming smaller and smaller. This is the case when r is a positive number. R is less than 1, but it is a positive number. What happens if r is less than 0? It is a negative number. Let us check. Okay, this time I am taking negative 0.5. I may take negative half, but it will be taking some more time. So I am taking negative 0.5 as negative half. Okay. So it is negative 0.5 to the power of, I start with say 10. It is this one. Next I take 100. 0.5 to the power of 100. See this. Okay. And you may wonder why are we getting the same value, because the power that I have taken is an even number. Therefore, this is equivalent to positive 0.5 to the power of 100. So let me take some odd power. Okay. So it will be negative 0.5 to the power of, say, I am taking 1001 this time, just to make the power odd, for no other reason. And you see it is 10 to the power of negative 302. So you can understand, and since these were even, the powers were even numbers, therefore you were having positive values. That is also one thing that has to be noted. Since the power is odd, you are having a negative value in this case, but it is an extremely small negative number. Okay, this is 1001. If I take say 99, you will be seeing that what happens. To the power of say 99. Negative 30. So as we have moved to from 99 to 1001, the number has become even more smaller. Okay, and these are negative numbers. So the number value is approaching 0 from the left hand side. If we think of the number line, then this is the number line. Okay, let me draw it. Yeah. This is better. So if we take this number line and this is 0, so when r is equal to half, as we are increasing the value of n, the number is becoming smaller and smaller, and all of them are positive. Therefore, maybe the first one was over here. Next, as we are increasing the power of n, the value of n, it is approaching the value of 0 from the right hand side. And when r is equal to say negative half, it is approaching the value of 0 from the left. Okay. So that is what is written over here. When r value is lying between negative 1 to positive 1, the expression r to the power of n becomes increasingly smaller as n becomes larger and larger, and is almost equal to 0. It is not that the answer is equal to 0. They are not giving us a 0 answer, but it is either a very small positive number or extremely small negative number as n is increasing, as n is approaching positive infinity. Okay. Therefore, for extremely large values of n, okay, let us take 10,000. So it is negative 0.5 to the power of 10,000. Let us try to find the value. Oh, sorry, by mistake I have taken 1000, sorry. So 0.5 to the power of 10,000. Okay. They are giving us a value of 0. And this will be the case if we take, instead of negative 0.5, if we take positive 0.5 as well. Let me show that. 10,000. It is also equal to 0. See? It may be a negative half or a positive half. When I have raised it to a power of 10,000, it is giving us a value of 0. So that is what we have seen. It is approaching the value 0 as n is becoming larger and larger. So for this formula, this part was equal to 1 minus r to the power of n, and this part is equal to 0. For extremely large values of n, this part is almost equal to 0. So 1 minus 0 is 1. Therefore, the numerator is only equal to u1 over 1 minus r. And this is the formula for the sum total of an infinite geometric series. And this is applicable only when the geometric series is having a common ratio between negative 1 and positive 1. And in this case, because it is not having any n in this formula, therefore u1 is fixed, r is fixed for the infinite geometric series. Therefore, we may say that the series converges to the said value. It will be having a definite value, and it does not get changed if we change the value of n. N can be made larger and larger, but it will not be affecting this result because this does not contain any n. So we say that the series converges to the said value, and therefore an infinite geometric series is said to be convergent when the positive value of r, absolute value of r is less than 1, or r is between negative 1 and positive 1. Okay. So now you understand why did I say the answer to be both yes and no. We may find the sum total of an infinite geometric series when the common ratio for that series is lying between negative 1 and positive 1. But it is no when r is more than 1 or when r is less than negative 1. Okay. So now we know the formula for infinite geometric series. This is equal to u1 over 1 minus r, and let us now try to solve the very first question on this topic, infinite geometric series, by the use of this formula, using this formula. Okay, u1 over 1 minus r. Find the sum of the following infinite geometric series: 18 minus 12 plus 8 minus and dot dot dot. It is an infinite geometric series, so let's start with our answer. So what is u1? u1 is equal to 18, and what is r? Because r value will be deciding whether or not we can find the sum total of this infinite geometric series. Okay, so it is negative 12 over 18, which is 6 times 2 and 6 times 3. So it is equal to negative 2 over 3. And negative 2 over 3 is definitely less than 1, and negative 2 over 3 is definitely greater than negative 1, because r value should be lying between negative 1 and positive 1. Only then can we say that the infinite geometric series will be converging to a particular value. And negative 2 over 3 is more than negative 1 and less than positive 1. Therefore, we may get the sum total. Okay. And since it is an infinite geometric series, so the number of terms will be infinity and we have to write S infinity. Okay, so here I have written Sn. It is actually S infinity is equal to U1 over 1 minus R. This is the formula for the sum total of an infinite geometric series which is having the common ratio between -1 and +1. Okay. So this is equal to S infinity equal to U1 is equal to 18 over 1 minus R. So 1 minus 2 over 3. Okay. So this is equal to 18 over 1 plus 2 over 3. And what is 1 plus 2 over 3? This is 3 over 3. 1 can be thought of as 3 over 3. Plus 2 over 3 will be 5 over 3. So this is S infinity is equal to 18 over 5 over 3. So this can be written as 18 divided by 5 over 3. Or this is 18 times 3 over 5. Okay. And we can get this, 18 times 3 is equal to 54 and over 5. So 54 over 5 is equal to 50 is 10.8. You can use a calculator as well. See, 18 times 3, so it is 18 times 3 divided by 5, 10.8. Okay. So S infinity is equal to 10.8. 10.8 is our answer. S infinity. So students, let us stop over here for now. We'll be meeting very soon in our next session. Thank you for watching this video till the end. Please give this video a like if you have found it useful. Please subscribe to my YouTube channel and do not forget to press the bell icon. You will be getting notified as soon as I publish a new video. I'm making videos on the IB and the IGCSE math curriculum chapters, and I am making videos each day from Monday to Friday. So you'll be getting a new video each day from Monday to Friday, and I hope you will be finding these videos useful in your math classes. Okay? Please do write to me about your feelings, about how you are benefiting, whether at all you are benefiting by watching these videos. Please do write to me in the comment area. Okay? So bye for now.